In this explainer, we're going to break down the entire process of deploying AI solutions. We'll cover how you take your brilliant code from your laptop and turn it into a real, reliable, and scalable service that anyone can use.
All right, here's our game plan. We'll kick things off by defining what we actually mean by AI deployment. Then, we'll look at the different options you have, from quick and dirty demos all the way to full production setups. The heart of this is going to be a deep dive into Google Cloud Run. After that, I'll walk you through a simple 4-step guide to get your own service live. We'll finish up by covering some absolutely crucial AI-specific configurations, and then wrap up with how to pick the right tool for your specific job.
So, first things first, what is AI deployment really? It's all about that journey from code that works on your machine to a service that works reliably for everyone, everywhere.
To put it simply, deployment is the whole process of getting your AI solution out there in a way that people can actually depend on it. And this is the key point. It's not just about uploading code. It's about Betrieb. It's about operations. It's about building and maintaining a service that lives and breathes on its own.
So why is this so critical? Well, without a proper deployment process, you've just got a science project. A good deployment strategy makes your solution accessible to users. It gives you stability and the ability to scale so you don't crash the moment you get a little traffic. It finally solves that classic, well, it works on my machine problem. And of course, it handles all the grown-up stuff, securing your API keys, monitoring performance and costs, and making the whole thing maintainable with versioning and rollbacks.
Okay, let's talk options, because there isn't just one way to do this. The tool you choose should match the phase your project is in, whether it's just a demo or a full-blown production system.
You can think of it in two big camps. For prototyping, sure, you can run a local server with something like FastAPI, or even serve directly from a notebook. It's super fast, great for testing ideas, but it's fragile, and it won't scale at all. For production, you're looking at cloud platforms like GCP, AWS, or Azure. These are built to be stable, scalable, and secure. Yeah, they take a bit more setup, but they're built for the real world.
And if you just need to share something quickly, there are some fantastic platforms out there. Hugging Face Spaces is amazing for showing off models with a nice UI. Google Colab is perfect for tutorials and proof of concepts, but definitely not for a live service. And Replit is a lifesaver for things like hackathons. You can get started and deployed right from your browser.
All right, now for the main event, a deep dive into Google Cloud Run. The reason we're focusing on this is because, for many AI applications, it really hits the sweet spot between the power you get from containers and the simplicity of serverless.
So what's the big idea here? It's beautifully simple. You package your application into a stateless container, a Docker image, and you give it to Google. Cloud Run then just executes that container whenever an HTTP request comes in. You don't worry about servers, scaling, or infrastructure. You just provide the code, and Google handles the rest.
Now this is what a really solid, recommended architecture looks like. You've got your user interface, which makes a call to your API. That API is a Cloud Run service, very often running FastAPI, that loads your model when it starts up and provides a /predict endpoint. Your big model files live in cloud storage, and all your secrets, like API keys, are safely tucked away in the secret manager. It's clean, it's secure, and it's incredibly powerful.
Okay, enough theory. Let's get practical. I'm going to show you how to go from your local code to a live, public URL on Cloud Run in just 4 main steps.
Step 1. You have to make your app container ready. This just means it needs to listen for requests on a port that's specified by an environment variable called port. Cloud Run sets this for you automatically. And a pro tip for AI apps, always load your model as soon as the application starts. This is key to keeping latency down.
Step 2 is to create your Docker file. Think of this as the recipe for building your container. You'll want to start with a slim base image to keep things fast. Then you'll copy in your code, install all your dependencies from your requirements.txt file, and finally, you'll specify the command to actually start your server, like Uvicorn if you're using FastAPI.
For step 3, you take that Docker file, build the actual image, give it a version tag, and then you push it up to Google's artifact registry. This is basically a private, secure garage for all your container images just waiting to be deployed.
And finally, step 4, the magic moment. You deploy your Cloud Run service. You just tell it which image to use from the artifact registry, you configure a few things like the region, memory, and CPU, set up your access rights, and you hit deploy. Just like that, you get a secure, public HTTPS URL for your AI service. It's awesome.
Now, getting a service up and running is great, But for AI workloads in particular, there are a few specific settings that can make or break your performance and your budget. Let's dig into those details that really make a difference. Concurrency is a huge one. This setting tells Cloud Run how many requests a single instance of your container should handle at the same time. Now, if your AI model needs a lot of RAM for each prediction, you want to keep this number low, maybe between 1 and 10. This prevents memory overload and keeps your latency predictable. On the flip side, if you have a really lightweight model, you can crank the concurrency way up to maximize how much work you get out of each instance, which is great for your bill. Next up is the classic cold start dilemma. It's a trade-off between cost and latency. By default, Cloud Run scales down to 0 instances when it's idle. This is fantastic for saving money. The catch? The first request after a quiet period will be a bit slower because an instance has to spin up. That's the cold start. If every millisecond counts and you need consistently low latency, you can set min instances to 1. This keeps one container warm and ready to go at all times, but you will pay for it to be running 24/7.
And here are 3 other critical settings to get right. First, timeouts. Some models take a while to run inference, so make sure your request's timeout is long enough to let them finish their work. Second, secrets. Please never, ever hardcode API keys in your code. Use a tool like Secret Manager and inject them as environment variables. It's way more secure. And finally, security access. You can make your service public for the whole world to see. Great for demos. Or you can lock it down with IAM so only authorized internal services can access it.
Okay, let's wrap this all up. If there's one thing to take away from all this, it's that you need to be strategic and pick the right deployment tool for what you're trying to accomplish.
So, the bottom line is this. For getting quick demos and proofs of concept out the door, platforms like Hugging Face or Replit are absolutely fantastic. They're fast and easy. But when you're ready to get serious, when you need something stable, scalable, and truly production ready, a solution like Google Cloud Run gives you the perfect balance of power, simplicity, and control for most modern AI applications.